Okay, this is another question from May 24, and it's a paper 1 on calculator paper, and that's for total 8 marks. Quite a long question, but there's a few things to kind of discuss there, but let's start one by one. A function is defined by f of x is equal to 2 times x plus 3 over 3 times x plus 2, where x belongs to R, again all real numbers, right? But x cannot be equal to 2. That's basically coming from the fact that the denominator is the 3 times x plus 2, and this cannot be equal to 0, otherwise we would be having a format which is a over 0, right, which is not desirable. So that means that the x cannot be equal to -2, and therefore we don't run into this problem. Okay, the graph is seen below. So for 1 mark, and that will mean just to write the answer, write down the equation. The equation is an important part of the horizontal asymptote. This is the horizontal asymptote, and this is the vertical asymptote. You should be familiar with that terminology so you know what you're doing. And then writing equations of lines parallel to the x-axis, they're always going to be in the format y equals to something. Therefore, the equation of the horizontal asymptote is going to be the y is equal to whatever point it crosses the y-axis, which is equal to 1. So y is equal to 1, and that's your horizontal asymptote. If by any means you were asked to write down the vertical asymptote, then we can put it here as vertical asymptote. That's going to be the x is equal to -2, because all the lines that they are perpendicular to x-axis or parallel to the y-axis, they have the format x is equal to something. Given that opportunity, let's just write the equations for the x-axis and the y-axis as well. That's just a bit of a revision. So the x-axis has an equation y is equal to 0, whilst the y-axis has an equation x is equal to 0. And if that confuses you, that would be because any point on the y-axis is going to be the 0,3, and then it's the 0,4, and then it's the 0,5, and so on. So basically, if you just check what they have in common, the x-coordinate is equal to 0. That's like a quick explanation why we ended up with x is equal to 0. Moving on, write down the number of solutions of f of x equals g of x for m bigger than 0. I didn't read the full question. So consider a g of x which is equal to mx plus 1, where m belongs to R and m cannot be 0. M cannot be, first of all, this is a linear function, right? And for m not being 0, excuse me, that means that you're not going to end up with the equation that y is equal to 1, which is the horizontal asymptote we just discussed before. So there's two different options. We know that it goes through number 1 because the y-intercept is the 0,1. So basically that's the point we have marked already before. And then if m is positive, what we're going to end up with, a line that goes upwards, so it's going to be a bit like that. Therefore, you have one point of intersection here and another point of intersection here. Whilst if m is negative, then you might end up with a solution like this one that has 0 points of intersection, or if m is even more negative than the one that I drew before, then you might end up with 2 points of intersection when you might be having one here and one here. So let's read the question again to identify what we're talking about here. Consider a linear function that we already had this conversation. Yeah, m cannot be equal to 0, so therefore it's not going to be parallel to the y-axis, and in this case it won't be the horizontal asymptote. Write down the number of solutions when m is positive. Okay, let's clear that up. So we see what happens when m is positive. So when m is positive, right, the fixed point is going to be the 0,1 that is going to go through it. And then we're talking about the case that you can see up there. Therefore, the number of solutions is going to be number of solutions is going to be equal to 2. You better write the sentence like number of solutions is equal to 2. That will qualify for the second full mark.